We are about to discover a new planet in the solar system. And it's huge. The solar system, vast and mysterious, has always held its secrets close. For centuries, humanity has gazed into the night sky, mapping out planets and stars, believing we understood our cosmic neighborhood. But what if we told you that something monumental, even colossal, is lurking beyond the familiar boundaries of Neptune? What if a massive, hidden planet, one that could rival or even exceed Earth in size, awaits discovery? Buckle up, because we're on the verge of uncovering one of astronomy's most tantalizing mysteries. Let's start with what's familiar, our solar system as most of us know it. Mercury, Venus, Earth, Mars, the gas giants, Jupiter, Saturn, Uranus, and Neptune, and the host of dwarf planets like Pluto, all neatly orbiting the Sun. For decades, we considered these the primary residents of our solar system, seemingly permanent and finite. But history proves otherwise. In the 19th century, Neptune was discovered because astronomers noticed Uranus wasn't behaving quite as predicted. Its orbit hinted at the pull of an unseen planet. Decades later, Pluto was added to our charts, only to be reclassified as a dwarf planet. These discoveries taught us an important lesson: the solar system isn't static. It changes as our tools, math, and understanding improve. Today, that same lesson echoes louder than ever. Strange movements of objects in the Kuiper Belt, a region of icy bodies beyond Neptune, have once again raised questions. Questions that could lead to one of the biggest discoveries of our time. While observing the icy, rocky bodies in the Kuiper Belt, astronomers began noticing something curious. Many of these objects weren't following the orbital paths they should. Instead, they seemed to cluster together in ways that defied explanation. These anomalies were no mere coincidence. Mathematical modeling and orbital simulations revealed that their peculiar behavior wasn't random. Something, a massive body, must be exerting a gravitational force on these objects. But what could it be? A rogue star? A black hole? Or a hidden planet? The idea of a hidden planet beyond Neptune isn't new. For decades, scientists speculated on the existence of an undiscovered world in the outer reaches of the solar system. But it wasn't until recently that the evidence became compelling enough to reignite a full-scale search. The mysterious celestial body theorized to explain these gravitational tugs has been nicknamed Planet 9. And if it exists, it's no ordinary planet. Planet 9 is predicted to be enormous, at least 5 to 10 times the mass of Earth. Its orbit would lie far beyond the familiar planets, taking thousands of years to complete a single trip around the Sun. In the dark, icy expanse of the solar system's outer edge, it lurks unseen, too faint to spot with current telescopes but exerting a gravitational influence strong enough to leave its mark on smaller objects. To imagine Planet 9 is to envision a world bathed in perpetual darkness, orbiting billions of kilometers from the Sun, its frigid surface possibly covered in ice or gases. This isn't just another addition to our solar system, it's a behemoth that could rival Neptune in size, a world waiting to be found. The journey to find Planet 9 has been one of patience and ingenuity. Using mathematical models, astronomers trace the orbits of distant Kuiper Belt objects, looking for subtle signs of Planet 9's existence. They tweak simulations, accounting for its immense mass and far-flung orbit, slowly narrowing down the possible regions where this hidden world might be hiding. Modern telescopes are also part of this extraordinary hunt. The Vera Rubin Observatory, set to become operational soon, holds the promise of scanning vast areas of the sky with unprecedented precision. Its massive survey will look for faint moving dots, an indication of Planet 9 sneaking through the distant cosmic darkness. Yet, locating the planet is no easy task. Given its hypothesized position, Planet 9 would reflect very little sunlight and move incredibly slowly across the sky. It's like searching for a single grain of sand in an endless desert, but the clues are there, leading scientists ever closer. While scientists haven't visually confirmed Planet 9 yet, the circumstantial evidence supporting its existence is difficult to ignore. The clustered orbits of small, icy objects like Sedna and others in the Kuiper Belt strongly suggest an unseen gravitational pull. Additionally, computer models simulating the solar system without Planet 9 fail to explain these peculiar orbital patterns. Some skeptics argue that these anomalies might result from other factors, like interactions between Kuiper Belt objects themselves. However, the strength and consistency of the anomalies leave Planet 9 as the most likely explanation. The case isn't closed yet, but the hypothesis grows stronger with accumulating data. If Planet 9 is truly out there, it's not just another planet, it's a game changer. Its sheer size places it between the terrestrial planets like Earth and the ice giants Uranus and Neptune, making it a kind of super-Earth. Such planets aren't seen in our solar system but are surprisingly common around other stars. Its orbit, tilted and elongated, challenges traditional models of solar system formation. How did such a massive planet end up so far away? Was it flung outward by gravitational interactions with Jupiter or Saturn billions of years ago? Did it originate elsewhere in the galaxy and get captured by the Sun's gravity? Each possibility opens the door to fascinating new questions about the universe. Discovering Planet 9 won't just add a new entry to the list of planets, it will rewrite our understanding of the solar system. It will showcase the Sun's immense reach, extending far beyond what we once imagined. It could even inspire new theories about planetary formation, migration, and the dynamic nature of our cosmic home. But the implications go even further. A confirmed discovery would trigger a search for similar hidden objects in our solar system. What other celestial secrets might our star system still be hiding? Moreover, finding a super-Earth in our own solar system could deepen our understanding of exoplanets, worlds orbiting distant stars. If Planet 9 shares characteristics with these distant planets, it could serve as a local laboratory to study them up close. The hunt for Planet 9 is more than a pursuit of science, it's a testament to human curiosity and our audacious desire to explore the unknown. Just as the discovery of Neptune, Pluto, and the Kuiper Belt expanded our horizons, Planet 9 reminds us that the solar system is still full of surprises. Astronomy is often about finding the edges of knowledge, and this search is no different. It challenges us to look deeper, follow evidence wherever it leads, and embrace wonder at the immensity of the cosmos. As we journey closer to confirming, or perhaps even spotting, Planet 9, one thing becomes increasingly clear: the solar system is not as simple as we once thought. It's a dynamic, ever-evolving arena of discovery, inviting us to probe the edges of what's possible. What else might lie beyond the fringes of what we now know? Could there be even more surprises lurking in the vast void? The search for Planet 9 is, in many ways, the search for our place in the cosmos, an outreach of human curiosity reaching into the unknown. Until that moment when Planet 9 reveals itself, we are left to marvel at the possibilities and the power of science to illuminate the dark. So, keep looking up. The universe has secrets yet to share, and perhaps its next great revelation is just around the corner. The discovery of Planet 9, if and when it happens, will remind us of one simple truth: the cosmos is vast, mysterious, and far more complex than we can imagine. And that's precisely what makes exploring it so irresistible.